Namaste, my dear friends, and welcome back to the JavaScript series. Please try to understand, we were discussing promises. Now, how did we arrive at this promises concept? Basically, we understood that JavaScript is a synchronously executing programming language, step by step execution, sequential execution. But when things execute sequentially or synchronously, a fundamental problem that occurs is if there is a task which takes a lot of time, it blocks the other tasks. So the code becomes blocking code. And usually, this kind of code is such code where you're trying to fetch some data from some external server, because of which other tasks are frozen, because of which our entire UI gets frozen. To solve the problem of our synchronous execution, we understood that JavaScript offers us another way to execute called as asynchronous execution. We achieved asynchronous execution using web APIs such as set timeout, set interval, clear interval. But the way we achieve asynchronous operation or execution is by making use of a fundamental concept called as callbacks, which is functions provided as input to other functions. Now, whenever we write this callback type code, usually we arrive at a situation called as a callback hell, like what I'm showing you here. Syntax becomes unreadable. It's difficult to understand the logic, difficult to debug the logic. So, to avoid the callback hell, we understood that we need to come up with a better way, a refined syntax to achieve asynchronous operations. And that is where I introduced you to the concept of promises. And that is what the entire last 2 lectures was about. But let me tell you, promises is a great improvement compared to your callback hell, compared to your web APIs, etc. But there is an even more refined version, a even more beautiful syntax that you can write on top of promises, which is called as async await. Async await is not any new concept. It is promises itself. It's just that our approach and the way we write the code is what is fundamentally different. All right. So let me show you how beautiful async await can make our syntax. For that, let's get started with our first example. Now, in my VS Code, I'm going to write a simple example. What I'm going to do is I'm going to write a code which will make use of promises, which we are used to. Then I'll convert that into async await so that you can understand. Watch. I'll start by creating a function. I'll call this function as probably exmp. Now, this function essentially is going to return a new promise. I hope all this syntax you remember. Promises will always inside it take one executor function. And if anybody has come directly to this video, please go back and watch this particular lecture. You'll understand all of this. Inside the executor function, always a promise is going to take two things, which is resolve and reject, which are further callback functions. I've explained this. Next, it is inside this executor function where the asynchronous code is written. And the asynchronous operation can only be achieved using our web APIs, and I will be making use of our web API called as set timeout. Set timeout also is going to make use of callbacks, which I will write in the syntax of this arrow function. Inside this, let us assume some dummy task is executing, and I will say console.log, and here I will say task completed. Now, if the task is successfully completed, the promise will now enter a state called as the fulfilled state. Initially, it will be in a pending state. If it is successful, it becomes fulfilled. If it is unsuccessful, it becomes rejected state. All this I've explained previously. Any which ways, I will now come below this. And what are you going to do if you ask me? It's very, very simple. I will now call resolve because it is resolve which you have to call if it is successful. Now I will come outside this promise, and please try to understand, when I call exmp is returning a promise. Whenever a promise is returned, automatically first its executor function will automatically execute. Inside that, the set timeout will execute. Inside that, this task gets completed. And when I call resolve, upon successful resolution of a promise, what we will now be calling is then. Upon unsuccessful or rejection of a promise, we will be calling catch. All this I've explained. Inside this, then also it will accept a callback, which I will write as an arrow function. Inside catch also it will accept a callback, which I will show as an arrow function. All this I've explained. Inside this, I'll just go and one simple message console.log, and I will say probably promise fulfilled. I hope my spelling is right. And here, I'm going to copy this console.log statement, paste it inside this callback of catch, and there I will say promise failed. I'm getting an error because there should not be a semicolon after then. It should only be after catch. Clear? Beautiful. Now what are we going to do next? Listen to my words carefully. Now, I would like to quickly show you how this executes. Though you are aware of it, let's try to trace the program. This is my memory in my computer, which helps my JavaScript program execute. I have my call stack, I have my web APIs, I have my macro and micro task queues. Now listen to me carefully. First thing that happens in any JavaScript program is its global execution context gets created inside the call stack. What executes inside the global execution context is such code which is present outside all the functions in JavaScript. And what is present is now this line. Now when I call exmp, JavaScript knows it has to execute this example function. Whenever a function is called, its own execution context gets created. Now we are executing this exmp. Now inside exmp, what are you doing? You are now returning a new promise. Whenever you create a promise, I've told you its own promise object gets created. Inside the promise object, its state is maintained, and the initial state of every promise is that of pending. It's pending. It's neither fulfilled nor rejected. Now, whenever a promise object is created, automatically its executor function will execute. Inside the executor function, I'm using a web API called as setTimeout. Whenever you call setTimeout, this callback function that you have given inside setTimeout will not automatically execute. Instead, it is registered inside the web API that there is a callback which has to have a timer, and the timer that I have given here, I have forgotten to give a timer here. If you don't give anything, it is 0. I will give it as 3000. Now it will maintain the timer 3000, which is nothing but 3 seconds. Understood? Now please try to understand. Once so much happens, exmp's execution is done, it gets removed from the call stack. Once it gets removed from the call stack, control again comes back to the global execution context, where all I had done was I had called exmp, then and catch depends upon whether the promise was successful or unsuccessful. Anyways, global execution context is also done, it also gets removed. Once this much happens, now there is an asynchronous code in the web API with a timer. 3 seconds becomes 2, 2 becomes 1, 1 becomes 0. The moment it becomes 0, the callback gets added to the macro task queue. I've already explained it to you. Understood? Now, the event loop, which is our traffic police, checks whether the call stack is empty. If it is empty, it now checks, is there anybody ready to execute in the macro task? Yes, there is a function ready to execute. Immediately it inserts it into the call stack. And it is now that this callback function inside setTimeout will execute. Where now I will get task completed, logged on my screen, and then I'm calling resolve. When I call resolve, what happens? Please try to understand. Resolve will automatically take control to then. Then we'll now see that there is a callback inside then. Now this callback will not automatically execute. All the callbacks present within then and catch, or in other words, whatever callbacks is associated with a promise, gets automatically added to the micro task queue. Understand what I'm trying to say? That's it. Now this function is also done. It gets removed from the call stack. Event loop checks, is the call stack empty? Yes. The moment it is empty, it sees that there is somebody in the micro task queue waiting to execute, inserts it. And now this micro task which got inserted will get executed, which is nothing but this callback where I'll get promise fulfilled. That's it. After that, even that gets empty. This I've already explained, but I just wanted to give you a refresher. Now, please try to understand. I will convert the syntax into a asynchronous async await function. I'll use that syntax and you'll see the syntax becomes much more cleaner to understand. Okay. Everybody should try to understand what I'm saying. Now watch this carefully. How do you convert this? See, this remains the same because ultimately async await is nothing but promises only. You have to ultimately create a promise. So I'll not touch this. Instead, it is this code which is not very logical to read. It's not very easy to read. Understood? So what I will do is, I will remove all of this. And I am going to create one function which I will call as run. Understood? Now, this function run, inside that, I am now going to call this function called as exmp. But what is exmp? Ultimately, it is a promise. So see what I will do. I'll call this exmp function, and now instead of saying then, catch, all of that, I will come this side and say, listen JavaScript, exmp is a function inside which I have a promise, inside which I have some asynchronous code. This will take some time to execute. You do one thing, you please wait for this person to finish execution by saying await. Wait for exmp to finish execution. Understand what I'm trying to say? Now the moment you see await, you can see there is an error. Reason. Whenever inside a function you make use of the keyword called as await, compulsorily the function should be declared as async. The moment I said async, await, error disappeared. You're telling JavaScript that, hey JavaScript, run is a function inside which asynchronous code is executing. So you may have to wait. Async, await. Asynchronous code, which you need to wait for. Async, await. Is this much clear to everybody? Now, you can see, now what happens is, please try to understand, when I call exmp, it's a promise. It'll execute. If the promise is successful, then automatically I will come to the next line. In the next line, what I will do is, whatever I did previously, which is I'll just tell console.log, and I'll just put a simple message where I say, promise fulfilled. That's all. Understood what I'm trying to say? Really, sir? Now, see, it becomes so easy to read. Now, also, obviously, you'll have to call this function called as run. Without calling, no function will run. Right? Understand? I'm calling this function called as run. Inside this run function, I'm going to wait for execution of exmp to complete. If exmp successfully completes, I'll come to the next line. Sir, if it is unsuccessful, what you'll do, sir? That I'll show you. But can we just look at this much? Try to watch this. I'll again bring back my memory diagram. First thing that happens is global execution context gets created. Code which is outside all of the function will execute, and that is only one code run. The moment I call run, run function gets created on the call stack. Please understand, what is the code which always automatically comes to the call stack? Synchronous code. So it is just synchronously only executing like any other normal JavaScript code. It comes into the call stack. Next, when I come inside that, please try to understand. Now listen to my words carefully. We encounter a word called as await. The moment you see await, now JavaScript does something very interesting. What it does is, it now realizes that it has to call this function called as exmp. But exmp is going to take some time. So see what will happen. Now, I will call exmp. Exmp, that is this function, its own execution context gets created. But this run function, that function will now get suspended. It will get suspended. I am removing it from the call stack and it goes into a suspended state in the web API. That is the beauty of an asynchronous function. Suspended. It just waits. Now who is executing? exmp. What is EXMP returning? Promise. Same thing. Promise object gets created, status initially pending, after the executor function gets executed, inside that set timeout gets registered, 3 seconds delay is there. After which, please try to understand, EXMP is done, it gets removed. Once it gets removed, control comes back to the global execution context. There is nothing remaining. That also gets removed. Now try to understand what happens. The timer from 3 becomes 2, becomes 1. After that, it enters into the macro task. Event loop checks there is nobody inside the call stack, puts this inside the call stack. And now this callback executes where I'll get task completed. And now listen to me. When you say resolve, now JavaScript knows that this promise was successfully executed. It changes the state from pending to fulfilled, after which immediately it knows that there was an asynchronous function which was suspended and waiting for this particular operation to finish. Automatically it takes it from the web API, puts it back into the call stack. Understand what I'm trying to say? After that, what happens? Now from wherever it's paused, it resumes. Control comes to the next line, promise fulfilled, you get. After that, all the statements inside run function is done. Even it gets removed from the call stack. Everything becomes empty. Program execution is done. Now, ultimately, the last program in this program will give you the same output, but it becomes easier to read. Syntax becomes cleaner instead of all that dot, then dot, catch, all of that. Really, will this happen? You may ask. Yes, please watch. Step 1 started. Oh, sorry, I executed the wrong piece of code here. I should be executing test.js. So you can notice task completed, promise fulfilled. That's it. I hope this much clarity everybody has got. Understood? Great. But what if it fails, Rohit, you may ask? Valid question, genuine question. If it gets failed, now I will show you how you have to write the code. Watch this. Now what you need to do here, see, now I'll cut these 2 lines. I'll cut it. Now listen. Inside an asynchronous function, if you want to handle the success and failure of promises, you should use something called as try, and you should use something called as catch. Inside try is where I will put the await statement. Wait for EXMP to execute. After that, please, if it is successful, below that whatever is there you execute. But if in case it is unsuccessful, instead of resolve, let us assume it was reject. Then I will come to catch. In catch, I will handle the error. Now this error is just a variable. If I pass some data inside reject, that data gets collected inside this variable. That's all. Understood? For example, inside reject, if I just go and say failed, this failed will come and sit inside error. That's all. So reject may pass some data. That is why you should always collect it inside a catch. Understood? Anyways, I'm removing this. Now watch it, all of you. Now I'll come here, and what I'm going to essentially do here is I will now go and just tell console.log, and here I will say promise failed. Now watch it. I don't think I need to show the memory. Everything remains the same. It's just that instead of this try, we will execute catch. Now if I were to come here and if I were to execute this, you can notice task completed, promise failed. Hence it came to catch. If you don't give this catch, then you would have got an error here. I'll just show that to you. If I remove this catch, if I remove this try, and if I just close this bracket. Now watch. If I execute, now when it fails, There is no catch. There's nobody to catch the failure. And hence I'll get a error. I hope you're able to understand. So, and see what it is telling? Unhandled promise rejection. Unhandled promise rejection. Okay, great. So here let's go clear the screen, come back here, and let me undo this. Appearance becomes very, very clean to read. Now, what you need to understand is you understood this beautiful, but now you need to to show you the actual use of async await. I should now go to the previous program we wrote yesterday. Do you remember this was the program where step 1 was an asynchronous operation? The step 1 success depends, step 2 will execute only if step 1 is successful. Similarly, step 2 is also a promise. Next, step 3 will execute only if step 2 is successful. Then step 4 will execute only if step 3 is successful. And this is how we had written the code. So please understand, if promise of step 1 is successful, then step 2 executes. If that promise is successful, then step 3, then step 4. Then if step 4 is successful, this will execute. If anywhere any problem happens, catch. Now the problem is this is not very readable code. Yes, compared to that callback hell, this is much, much better. Way better. But the same thing if I have to do using async await. See what I will do? Very simple. I'll create a function called as run. I will say run function, be careful. Inside you, there will be some asynchronous codes which will be executing. So I'll make it async. Next, what I'll do here is very simple. I will first call the step 1 function. Step 1 function is going to give me a promise. Now, for this promise to either resolve or reject, it is going to take some time. It's an asynchronous operation. So I'll just come here and I will say, boss, listen, please wait. Await. It will wait. If it is successful, then control comes to the next line. And in the next line, I will call step 2. Now, step 2 also will take time. I will say, please wait. Only if it is successful, I'll come to the next line. I'll call step 3. Step 3 also will take time. So I will say, await. Only if it is successful, I'll come to the next line. I'll call step 4. Step 4 also may take some time. So I will say, await. Understood? That's it. And if step 4 is also successful, then I will come and say console.log, and here I will say promise fulfilled. But anywhere in these steps, if problems happen, then the rejection I should catch, and that is where we will put try, we will put catch, inside catch I will say error, like this. And these statements I will just put it here. Understood? Like this. Let me indent it correctly. And this also. If any issue happens, then I will come inside catch and I will just say promise failed. Clear, dear friends? Now all of you should focus. Here also I am calling resolve. Here also I am calling resolve. But here I am calling reject. So instead of reject, let's make it all resolve only, so that you understand how this works. So watch this carefully. Now if in case I execute, and of course, you should always call this function run, otherwise not execute on its own. Now if I go here and if I were to execute this time it is exmp.js, that is the last program that I had written. Now if I execute it, step 1 started. Only if it is successful, automatically step 2. Yes, only if step 2 is successful, then step 3. If step 3 is successful, step 4. And I'm getting step 3 failed here because unfortunately the message here was that of failed. If it was successful, then you would have got that message only. So don't get confused by that. See, step 1 started, successful, step 2. Wait for step 2. Once step 2 is successful, next line. Wait for step 3. If it is successful, step 4. Once it is done, promise fulfilled. Very easy to read, very easy to understand. Clean syntax. Am I clear? Of course, Let us assume somewhere, let us assume in step 3, instead of success, it failed. And instead of resolve, it was reject. Now watch it. If I were to come here, clear the screen. Now watch. See, step 1, it'll wait. Once it's successful, only step 2. Now it'll wait. Once it is successful, step 3. But step 3 will fail. Failure will come to catch. And I'll get promise failed. That's it. I think everybody understood async await, which is nothing but promises only, but a better syntax to write. It's very simple. When you have complicated promise chaining, instead of writing, dot, then dot, then dot, then dot, then, just take all of that logic, put it inside a function. Call it whatever you want, but tell JavaScript that there are asynchronous operations running. If you put async, you can use await. If you don't put async, you will get error here. Then you start. Simple try catch. And more about this try catch in depth I will be teaching you when I explore the concept of error handling in JavaScript, which I have not yet taught you. Now, one more thing is, there is no need for you to every time put this inside a function, an asynchronous function, not required. In the latest version of JavaScript, they have told, programmer, even if you do not put all this inside any function also, it will still execute. You can directly write try catch and write like this also. It will still work. As I can show you, still works. So earlier, if you were using await, compulsorily it had to be inside a function which was async. But now it is optional. You can directly write it outside also. So this is one point which I wanted everybody to know. Great, awesome. And this concludes whatever you had to know about how to handle asynchronous operations. Many experienced developers also struggle with this. I hope I have broken it down in the easiest possible way. Anyways, my dear friends, thank you so much for tuning into today's class. I will catch you in the next class. Till then, please make sure to practice every single day and don't forget to like, share and comment. This really keeps us motivated. Bye-bye.